Welcome to our channel. Today, we're diving deep into the cosmic ocean, exploring some of the most fascinating facts about our solar system. From the scorching surface of Venus to the icy rings of Saturn, we'll uncover hidden wonders and unravel celestial mysteries. Prepare to be amazed by the sheer scale and wonder of the universe we inhabit. Our journey will take us past planets, moons, and asteroids, each with its own story to tell. We'll explore the forces that shaped these celestial objects, from gravity's pull to the explosive power of volcanoes. So, fasten your seatbelts and get ready for a cosmic adventure as we unveil the secrets of our solar system, from Venus to Io and beyond. Our first stop takes us to Venus, our nearest planetary neighbor. Shrouded in thick clouds, Venus might seem like Earth's twin at first glance, but don't let that fool you. This planet holds secrets that challenge our understanding of how planets behave. One of Venus's most peculiar features is its retrograde rotation. Unlike Earth and most planets that spin counterclockwise, Venus rotates clockwise. Imagine the sun rising in the west and setting in the east. That's everyday life on Venus. But the strangeness doesn't stop there. Venus rotates so slowly that a single day on this scorching world lasts longer than a Venusian year. To be precise, a day on Venus is 243 Earth days long, while a year is only 225 Earth days. This means that if you were standing on the surface of Venus, which I wouldn't recommend due to the extreme heat and pressure, you would experience sunrise less than twice a year. Now that's a slow dance with the sun. The question that naturally arises is, why is Venus such a cosmic oddball? Why does it spin backward and so slowly? Astronomers have proposed several theories to explain this peculiar behavior. One prominent theory suggests that a massive collision in Venus's early history could have knocked it off its original axis, causing it to spin in the opposite direction. Imagine the cosmic billiards game that must have been. Another theory proposes that gravitational interactions between Venus's thick atmosphere and the Sun could have gradually slowed down its rotation over billions of years. It's a reminder that even seemingly insignificant forces can have a profound impact over cosmic timescales. While we don't have a definitive answer yet, these theories highlight the complex and often chaotic nature of planetary formation and evolution. The universe is full of surprises, and Venus's retrograde rotation is a testament to that. Venus's peculiar rotation serves as a reminder that our understanding of the universe is constantly evolving. What we observe today is the result of billions of years of cosmic history, shaped by forces both familiar and unknown. As we continue to explore our solar system and beyond, we're bound to encounter more mysteries and surprises. Each discovery challenges our assumptions and pushes the boundaries of our knowledge. So, the next time you gaze up at the night sky, remember Venus, the planet that spins backward. Let it be a reminder that the universe is full of wonders waiting to be discovered, and that even the seemingly familiar can hold profound secrets. And who knows, perhaps one day, we'll unlock the secrets of Venus's retrograde rotation, adding another piece to the grand cosmic puzzle. Our cosmic journey now takes us to Jupiter, the undisputed king of our solar system. This gas giant is so massive that it could fit all the other planets inside it with room to spare. Jupiter's swirling clouds and vibrant colors hint at the immense power that lies beneath its surface. And among its many wonders, one stands out as a testament to the planet's turbulent nature: the Great Red Spot. For centuries, astronomers have observed this colossal storm raging in Jupiter's atmosphere, a swirling vortex of red-hued clouds larger than our entire planet. Imagine a hurricane so vast and long-lived that it could swallow Earth whole. The Great Red Spot is a testament to Jupiter's immense size and powerful atmosphere. It's a reminder that the forces at play in the universe can create phenomena of truly awe-inspiring scale. The Great Red Spot has been raging for at least 300 years and possibly much longer. To put that into perspective, that's longer than the entire history of the United States. This storm is so powerful that its winds can reach speeds of up to 400 miles per hour, twice as fast as the most intense hurricanes on Earth. Imagine being caught in a storm of that magnitude. It would be like a scene out of a science fiction movie. But despite its ferocity, the Great Red Spot is not a static feature. Over the centuries, astronomers have observed it shrinking and changing shape, a reminder that even the most powerful storms are subject to the forces of change. Some scientists believe that the Great Red Spot could eventually dissipate altogether, while others speculate that it could merge with other storms to create an even more massive vortex. Only time will tell what the future holds for this iconic storm. Studying the Great Red Spot provides us with a unique opportunity to learn about the dynamics of planetary atmospheres. By observing how this storm forms, evolves, and interacts with its surroundings, we gain insights into the forces that shape weather patterns on other planets, including our own. Jupiter's atmosphere is a giant laboratory, where we can study extreme weather phenomena that are impossible to replicate on Earth. The lessons we learn from studying the Great Red Spot can help us better understand our own planet's climate and weather patterns. And who knows, perhaps the secrets hidden within the swirling clouds of the Great Red Spot will one day help us unlock the mysteries of planetary atmospheres throughout the universe. From a distance, Saturn's rings appear as a solid, almost impossibly perfect disk encircling the gas giant. It's a breathtaking sight, a cosmic halo that has captivated astronomers for centuries. But let's shed some light on these enigmatic rings, revealing their true nature. These rings, my friends, are far from a monolithic structure. Imagine instead countless individual particles, each on its own unique orbit around Saturn. These particles range in size from grains of dust, smaller than a snowflake, to massive chunks of ice, some even larger than a double-decker bus. These icy fragments, remnants of comets, asteroids, or perhaps even shattered moons, are caught in a delicate gravitational dance. They collide, they shatter, they clump together, constantly changing and evolving over eons. And as they orbit Saturn, these particles bunch up and spread out, creating the intricate patterns and gaps we observe in the rings. What are Saturn's rings made of? Water ice mixed with rock and dust. The same ice you use in drinks. Imagine a moon made of this ice. The rings tell a story of chaos and creation. Saturn's rings aren't smooth. They're broken by gaps and divisions. These gaps are caused by the gravitational pull of Saturn's moons. The Cassini division, for example, is kept clear by Mimas. Other moons like Pandora and Prometheus act as shepherds. They herd the icy particles, maintaining the ring structure. We often take for granted the air we breathe, this invisible elixir that sustains us, but our atmosphere with its life-giving oxygen wasn't always this way. In fact, early Earth's atmosphere was a far cry from the one we know today. Instead of oxygen, our planet was shrouded in a toxic haze of methane, ammonia, and other gases. These gases, spewed out by volcanoes and present in the early solar system, would be deadly to most life forms today. It was an alien world, hostile and unforgiving. But even in this harsh environment, life found a way. Deep in the primordial oceans, single-celled organisms began to emerge, harnessing the energy of the sun through a process we now call photosynthesis. These weren't your average plants, though. These were cyanobacteria, microscopic pioneers that would change the fate of our planet. Cyanobacteria, also known as blue-green algae, possessed a remarkable ability. They could convert sunlight, water, and carbon dioxide into energy-releasing oxygen as a byproduct. It was a simple process, yet it would have profound consequences for the future of life on Earth. As these tiny organisms multiplied, they released more and more oxygen into the atmosphere. At first, this oxygen reacted with iron in the oceans, creating vast deposits of iron ore. But eventually the oxygen began to accumulate in the atmosphere, slowly transforming it from a toxic soup into a breathable haven. This great oxidation event, as it's known, was a pivotal moment in Earth's history. It marked a turning point, a shift from an anaerobic world to an aerobic one, paving the way for the evolution of oxygen-breathing life forms, including ourselves. The rise of oxygen had a profound impact on life on Earth. It allowed for the evolution of more complex organisms, organisms that could harness the power of oxygen to fuel their metabolisms. This led to an explosion of diversity, from the first multicellular organisms to the plants and animals we see today. But the legacy of cyanobacteria extends far beyond our own existence. The oxygen they produced also created a protective layer of ozone in the upper atmosphere. This ozone layer shields us from harmful ultraviolet radiation from the sun, making Earth a more hospitable place for life to thrive. So the next time you take a deep breath of fresh air, remember the tiny cyanobacteria. These microscopic organisms, through their simple act of photosynthesis, transformed our planet and made it possible for us to exist. From the vast swirling clouds of gas and dust, a pale blue dot emerged. Earth, our cosmic oasis, stands unique in its abundance of liquid water. But have you ever stopped to consider the journey of a single drop? It's a tale that stretches back billions of years. Water arrived through a series of cosmic events. Asteroids and comets carried frozen water locked in their icy hearts. These impacts delivered vast quantities of water to our planet. This water eventually created the first oceans, and within those primordial seas, life as we know it took hold. So, the next time you take a sip of water, consider this. Those molecules have existed for billions of years. They've cycled through oceans, formed clouds, and fallen as rain. Some were locked in glaciers for millennia, but the journey doesn't end there. Isotopic analysis reveals water's cosmic origins. Some water came from comets, some from asteroids. It's a cosmic cocktail, blending ingredients from our solar system, a testament to our planet's connection with the cosmos. "71% of Earth's surface is covered in water, vital for life itself. Yet, liquid water is rare in our solar system. Mars has water ice, locked in polar caps. Europa and Enceladus hint at subsurface oceans, possibilities for life. But these environments are different, water hidden beneath ice or rock. As we search the stars for planets with water, we seek life as we know it. The search continues, for another Earth. In the vast cosmos, we remain hopeful. Somewhere out there, a story of water and life unfolds." In the celestial tapestry of our solar system, Jupiter reigns supreme, a colossal gas giant orbited by fascinating moons. Among them, Io stands out for its unparalleled volcanic fury. Caught in a gravitational tug-of-war, Io's surface is a chaotic landscape of erupting volcanoes and lava flows. Imagine standing on Io with the ground trembling beneath your feet. Molten lava flows across the landscape, carving fiery rivers. Towering plumes of sulfur dioxide paint the surface in hues of yellow, orange, and red, a scene of terrifying beauty and awe-inspiring power. What drives this intense volcanic activity on Io? The answer lies in a delicate gravitational dance between Jupiter, Io, and two of its neighboring moons, Europa and Ganymede. Io's orbit around Jupiter is slightly elliptical, not perfectly circular. This means that the gravitational pull Io experiences from Jupiter varies throughout its orbit. As Io swings closer to Jupiter, the giant planet's immense gravity stretches the moon, creating a tidal bulge. When Io swings further away, the gravitational pull weakens and the bulge subsides. This constant stretching and compressing generate immense heat within Io's interior, much like the heat generated when you repeatedly bend a paperclip. This tidal heating is so intense that it melts Io's rocky mantle, creating vast magma chambers beneath the surface. This molten rock then erupts onto the surface through volcanic vents and fissures, feeding the moon's spectacular volcanic displays. The gravitational interplay between Jupiter, Io, and its neighboring moons acts as a cosmic tug-of-war, constantly kneading and flexing Io's interior, keeping it molten and volcanically active. Io's extreme volcanism makes it a fascinating world to study. By observing Io, we gain insights into the powerful geological processes that shaped our planet. Earth's volcanoes, though less intense, show our planet is geologically active. Earth's internal heat drives tectonic plates, causing earthquakes and mountain formation. Studying Io helps us understand planetary evolution. From the swirling clouds of Venus to the fiery heart of Io, we've journeyed across our solar system, uncovering the secrets held within these celestial wonders. We've seen how Venus, our sister planet, dances to the rhythm of a backward rotation, and how Jupiter's Great Red Spot, a storm larger than our entire planet, has raged for centuries. We've marveled at the shimmering beauty of Saturn's rings, composed of countless icy particles, and explored the origins of Earth's life-giving water and oxygen. The universe is an endless frontier of discovery, and our exploration of it has just begun. Each planet, each moon, holds a unique story, a testament to the vastness and complexity of the cosmos. As we continue to explore, to push the boundaries of our knowledge, we are reminded of the interconnectedness of all things, from the smallest atom to the largest galaxy. Thanks for watching. If you enjoyed these incredible facts about our solar system, don't forget to like, subscribe, and hit the bell icon for more amazing content. See you next time.